просмотре лекции можно остановить любой нужный вам кадр при помощи левой клавиши мыши, щелкая ей по экрану. Для того, чтобы найти нужный кадр, используйте внизу полосу прокрутки.
Auf dem Bild sieht man das ein bisschen besser. Zwei Laserscanner werden auf dem Schachtkorb montiert.
На крыше, значит, подъемника клетей монтируется два сканера.
Und rotieren.
Они вращаются.
Und während denn der Korb bewegt wird, wird das komplette Bild abgebildet.
Движется вниз, и она по спирали, значит, сканирует стенки.
Und außerdem die inertiale Messeinheit dort,
там расположено вот это самое инерциальное измерительное устройство,
die absolute Position des Schachtkorbes
которое отслеживает, измеряет абсолютное положение, значит, измерительного устройства.
Und um die Tiefe zu messen, gibt es auch noch hier eine Messeinrichtung für die Tiefe.
Кроме этого, есть еще устройство, которое измеряет глубину шахты, барабанное устройство.
Hier sieht man einige Bilder von der Montage.
Здесь несколько примеров монтажа.
Das ist ein Film, der das System einmal im Einsatz zeigt. Eine Animation. Ich hoffe, man kann etwas erkennen. Man sieht einen Schachtkorb. Dort werden jetzt die beiden Scanner montiert. Das kann individuell für jeden Schachtkorb angepasst werden.
Они могут подгоняться индивидуально под каждую шахту размера.
Scanner drehen.
Сканеры вращаются и перекрывают друг друга.
Messrad.
Это вот колесико для измерения глубины. Оно соединено с инерциальным измерительным блоком.
Für die Position.
Оно позиционирует.
Jetzt fährt das ganze System herunter. Das Inertialmesssystem zeigt die Position, wenn der Schacht also schief steht. Und der Scanner macht ein komplettes 3D-Abbild wie ein digitales Foto von den Schachtwandungen.
Как цифровая фотография трехмерная.
The initial section is excavated, 1 to 2 meters in depth. A support concrete ring beam is installed. It acts as a guideway and takes the forces from the shaft sinking process. The first segments of the shaft are assembled and lifted in place. These segments have an integrated steel cutting edge, which will act as a knife during the shaft sinking. Strand jacks are installed on the support concrete. Strand wires are connected to the first segments. The numbers of strands corresponds to the total weight of the shaft. The shaft is now held in position by this compact strand jack system. preparation for the machine installation starts by using a dummy frame to position the attachments for the machine, which are then welded to the steel plates cast into the concrete segments. The VSM machine is assembled to suit the shaft diameter and lifted into the shaft by a mobile crane and fixed onto the attachments. The rest of the shaft sinking equipment can now be installed. 3 winches are for lifting and lowering of the machine, for maintenance during shaft sinking, as well as to lift it out when the shaft is complete. The energy lines supply the machine with all necessary power and communication. This is an example of a complete site setup. All operations are powered and controlled from the container on the surface. Stored data, together with the position of the cutter boom, is shown on a graphic display, giving the operator full control of the excavation and sinking process. The cutter boom can either be controlled manually by the operator or set in automatic mode for cutting the set profile in a required section. The shaft is kept full of water during sinking to balance the level of groundwater in the surrounding ground. Various depths of the groundwater level can be handled. The flexibility of its telescopic arm rotation and slewing movements allows the cutter boom to work in shafts with between inner diameter of 4.5 and outer diameter of 11 meters in water depths up to 80 meters. The cutting arm moves radially from the center to the outside of the shaft. In soft soil, the cutting edge on the shaft is able to trim the excavation as it sinks into the ground. The cutting speed and the movement of the boom can be varied to achieve the best excavation rate. When it is necessary to excavate under the cutting edge, the machine can be fitted into an alternative position that is 1 meter lower. Where hard soil is encountered, the machine cuts out to the program limit all around the circumference before the shaft is lowered. In rock, this controlled descent allows all of the cutting edge to be cleared before lowering. This avoids either trapping the cutter boom or causing the shaft to deviate. A slurry circuit transports the excavated material from the shaft to a separation plant on the surface. The cutter drum cuts and crushes the material to a granular size that can be handled by the integral pump. In sticky ground conditions, an additional high-pressure feed line can clean the cutting drum. The separation equipment is selected to suit the local soil conditions. Precast concrete segments with rubber sealing gaskets are bolted in place on the top of the shaft. This can be done at the same time that the machine is excavating in the bottom, so the shaft sinking can go on continuously. The molds for the segments are also supplied as part of the shaft sinking equipment package. Segment dimensions are designed to suit the shaft's purpose. The daily sinking production is in a range of 1 to 5 meters, depending on the diameter, geology, and working hours. As an alternative to using segments to form the shaft, also in situ concrete can be used. Formwork designed for the shaft diameter is used to concrete the shaft lining in lifts of about 2 meters in height. The sinking process is the same as for shafts constructed with segments, This can be an advantage, for example, when the shaft is used to launch utility tunneling machines. The shaft wall can then be prepared with a built-in launch eye to suit exactly the tunneling equipment. An automatic lubrication system reduces friction during shaft sinking. The total number of nozzles is designed to suit the soil conditions. When the shaft is sunk to the required depth, the VSM machine is removed and the base plug concrete is cast. When the base concrete has gained sufficient strength, the water can be pumped out. The shaft construction has been completed without affecting the groundwater or the surrounding soil. The shaft is now ready to be used. History. Up till now, our VSM technology has been deployed for several applications. Here are some examples. For shafts up to 80 meters deep in St. Petersburg, Russia, the design also included the facility to push with up to 2,000 tons due to expected big boulders and complicated geology. The design is like a factory for continual production, and this was used for a number of shafts in Moscow. A machine has been built for dry excavation in soft to medium hard rock. The design includes a VSM machine in the bottom, rock bolting, and shotcrete sprayers above. Blind sinking procedures will be developed further, so in future various combinations can be used for the best technical solution.
Thank you.